You're standing in your kitchen tonight, and your phone buzzes with a message from someone 12,000 miles away. It arrives in seconds. You don't think about it. You just glance down and reply. But on the night of August 15, 1977, a machine sitting in a field in Ohio caught something that took decades to explain and might never be explained at all. It came from deep space. It lasted 72 seconds, and then it was gone forever. This is the story of the WOW signal. Here's what actually happened. A radio telescope called Big Ear, run by Ohio State University, was scanning the sky as part of a long, quiet search. Not for aliens exactly, for patterns, for anything that didn't look like noise. Most nights, it found nothing. That was the job. Space is loud with static, and the telescope's task was to sit there and listen through all of it, hoping for a signal shaped differently than the background hiss of stars and galaxies.
On this particular night, nobody was watching in real time. The data was being recorded onto paper printouts, long sheets covered in columns of numbers and letters, meant to be reviewed later by a volunteer astronomer named Jerry Ehman. Days afterward, he sat down with a stack of these printouts and began scanning them, one row at a time. Most of it was routine, small numbers, background noise. And then he saw it. A sequence of characters, 6EQUJ5, jumped off the page. In the telescope's measurement system, that string represented an enormous spike in intensity, far beyond anything nearby. Ehman didn't say anything scientific in the margin. He didn't write a hypothesis. He grabbed a red pen and circled it, and next to it, he wrote one word: WOW. That word stuck. It became the name of the signal, and eventually the name of one of the most famous unsolved mysteries in the history of science.
So what makes this so strange? Shouldn't a burst of radio noise be explainable? Usually, yes. Space is full of radio sources, pulsars, quasars, satellites, even earthly interference, like a passing plane or a faulty microwave. But researchers have spent decades trying to match the WOW signal to something ordinary, and none of it fits cleanly. The signal arrived at almost exactly the frequency scientists had long predicted an alien transmission might use, a frequency tied to hydrogen, the most common element in the universe. That specific number wasn't picked at random. It came from a 1959 paper by physicists Giuseppe Cocconi and Philip Morrison, who proposed that any advanced civilization trying to be heard across the galaxy would likely broadcast near that exact hydrogen line because it's a kind of universal landmark, something every species with radio telescopes would eventually notice. The WOW signal showed up almost precisely there. It also had another quality that made scientists lean forward. The signal rose in strength, peaked, and faded again over the course of about 72 seconds, matching almost perfectly the pattern you'd expect from something fixed in space as the rotating telescope's beam swept past it, then away. Not a glitch, not a spike, a shape. The kind of shape a real, distant source would produce, not the kind of shape random interference tends to leave behind. And then it never came back. Not that night. Not in the days after, when the telescope pointed at the same coordinates again and again. Not in any of the follow-up searches conducted over the following decades, using far more powerful instruments than Big Ear ever had. Whatever it was, it said its 72 seconds and went silent.
For years, the leading explanation involved comets.
Two researchers, Antonio Paris and Evan Davies, proposed in 2016 that a pair of comets passing through that part of the sky, releasing clouds of hydrogen gas, might have produced a signal strong enough to register. It was a serious attempt to close the case using known physics rather than speculation. But other astronomers pushed back hard, pointing out that comets don't typically emit radio signals anywhere near that intensity, and that the timing didn't line up as neatly as the theory required. The comet explanation didn't die completely, but it never became the consensus either. It just became one more theory, sitting alongside all the others, unable to fully explain what the printout showed.
Which leaves us in an uncomfortable place. Not because the signal proves anything about aliens. It doesn't. Careful scientists, including Jerry Ehman himself, spent the rest of his life cautioning people against reading too much into it. He knew the difference between a mystery and a discovery, and he never claimed to have found extraterrestrial life. What he found was something rarer, and in some ways more unsettling. A single, clean, unexplained event. A data point with no twin. Why does this bother us so much? This one recording for 1977. Maybe because we like our mysteries to resolve. We want the microwave to have caused it. We want the satellite to explain it. When neither one does, when the most likely conventional explanations keep falling short, we're left holding a fact that simply refuses to complete its own story.
There's a deeper reason this signal still matters, and it has to do with an idea proposed by astronomer Frank Drake, one of the founders of the modern search for extraterrestrial intelligence. Drake devised a way of estimating how many communicating civilizations might exist in our galaxy at any given time, weighing everything from star formation rates to the odds that intelligent life develops the technology to broadcast a signal at all. His equation isn't a prediction. It's a framework for thinking clearly about an almost unthinkable question. And one of its quiet implications is this. Even in a galaxy that might contain thousands of civilizations capable of sending a signal like the wow signal, the odds of catching one at the right frequency, pointed at the right patch of sky, during the exact 72 seconds your telescope happens to be listening, are almost impossibly small.
Which means, if the wow signal really was something intelligent, briefly aimed our way, we may have caught something we were never supposed to catch. A door that opened for just over a minute, decades ago, and then closed again before anyone could walk through it. Or maybe it wasn't that at all. Maybe it was some rare astrophysical event we don't have a name for yet. A phenomenon so uncommon that it hasn't repeated in the 50 years since, and won't again for 100 more. Both possibilities are strange in their own way. Both leave us exactly where Jerry Ehman left the printout, with a red circle and a single word, and no clean ending.
Astronomers have tried other approaches since then. In 2020, a researcher named Alberto Caballero attempted to narrow down which star the signal might have come from, cross-referencing the telescope's field of view with catalogs of nearby sun-like stars, eventually pointing to a candidate roughly 1,800 light-years away. If that identification holds up, it means whatever caused the signal, whether natural or something else, occurred near a star capable of hosting the kind of environment we associate with the potential for life. It doesn't prove anything, but it narrows the mystery down from the entire sky to a single point of light,
which is its own kind of progress.
Here's what's easy to forget about this story. It didn't happen in a lab full of scientists staring at screens, waiting for the moment of discovery. It happened in silence. A machine listened, alone, in a field, while nobody was paying attention. The evidence sat on paper for days before a human being even looked at it. There was no live alert, no control room lighting up, just a quiet review of printouts and a red pen circling 6 characters that didn't belong. Think about how much of the universe might work exactly like that. Not a dramatic reveal, but a quiet signal, arriving once, unnoticed in the moment, only recognized later, if at all. How many other 72-second windows have opened and closed above our heads while we were doing something else entirely? Loading the dishwasher, watching television, asleep.
We assume that if something extraordinary happened, we would know immediately. We assume the universe announces itself. But the wow signal suggests something colder and more honest. That contact, if it ever happens, might not look like a movie moment. It might look like 6 characters buried in a stack of paper, waiting patiently for someone to notice, days after the fact. Scientists have gone back to that same patch of sky many times since 1977, with instruments vastly more sensitive than Big Ear ever was. Nothing has matched it. Not once. The silence since then is almost as strange as the signal itself. Because if it really was a natural phenomenon, you'd expect it to repeat somewhere, sometime, in 50 years of increasingly sophisticated listening. It hasn't. Whatever caused those 72 seconds appears to have been a genuinely singular event, at least so far, in the entire recorded history of radio astronomy.
Big Ear itself is gone now, torn down in 1998 to make way for a golf course expansion. Its decades of data preserved mostly on paper and in the memories of the people who worked there. Jerry Ehman passed away in 2023, having spent nearly half a century fielding the same question from journalists and curious strangers, always giving some version of the same careful answer. It was interesting, it was unexplained, and it was not proof of anything. He never claimed more than the evidence allowed. That restraint is part of why the story still holds up.
So think again about your phone, sitting in your pocket right now, capable of reaching almost anyone on Earth in less than a second. We've built a world where communication feels instant, guaranteed, unremarkable. But somewhere out past the edge of what our instruments can reliably explain, a signal arrived once, said something we still can't translate, and left. Maybe it was hydrogen gas drifting off a comet. Maybe it was some artifact of equipment we don't fully understand, even now. Or maybe, just once, on a quiet night in Ohio, something reached across an unimaginable distance, found exactly the right frequency, and for 72 seconds, tried to say hello.
There's something almost humbling in how ordinary the moment of discovery actually was. No sirens, no breaking news alert, just a tired volunteer, a stack of paper, and a red pen moving across a page full of numbers until it found the one row that didn't belong. Science rarely announces itself the way fiction promises it will. Most breakthroughs arrive quietly, buried in routine data, waiting for someone patient enough to notice the anomaly instead of skimming past it. That patience is worth remembering. How many signals in how many fields have already been recorded and simply never reviewed closely enough? How many red circles are still waiting to be drawn? The wow signal isn't just a story about outer space. It's a reminder that the difference between noise and history sometimes comes down to whether anyone bothered to look twice.
We still don't know, and the not knowing is the whole point. Because the next time your phone buzzes in your kitchen and you glance down without a second thought, remember that somewhere above you, the sky itself has already sent one message we never managed to answer.